Good day guys, this is your tutor engineer. We are continuing today with graphs and motion on one dimension. So let's start with today's lesson. For each of the following position time graphs, determine the magnitude of the average velocity at each point as indicated in the graph. So 10.1, you have the displacement time graph. You need to get the average velocity between 0 and 5 seconds. So since you are given the displacement time graph and you need to work out the velocity, that means you need to work and calculate the slope, right? So under the displacement time graph. So let's calculate the slope to get the velocity. The coordinate here is 5 and 11 and the coordinate there is 0, 0. So let's calculate the velocity. We'll have x2 minus x1 divided by t2 minus t1. That means x2 is 11 minus 0. t2 is 5 minus 0. So the answer is 11 over 5, which is 2.2 meters per second in the positive direction. Now let's answer the same question for 10.2. We'll calculate the average velocity for this section up until 6 seconds from 0 second. So let's get to the coordinates. Here you have 6 and 20. There the coordinate is 0 and 20. Here is 10 and 0. So I want you to realize that the average velocity where the displacement is constant will be 0. But let's just do it so that you see how I got to a 0. Velocity is equal to x2 minus x1, t2 minus t1. x2 is 20 minus 20. t2 is 6 minus 0. So we'll have 0 over 6, which is 0 meters per second. And then for main figure 2, using the same formula, zero minus 20, 10 minus 6, we have minus 20 divided by 10 minus 6 is 4. That would be minus 5 meters per second. Okay, so let's go to 10.3. Here you've got 3 sections between 0 and 1. Let's work out the velocity or a slope. Here the coordinate is 1 and 2. And then here the coordinate is 3 and minus 3. Here you will have 2 and 0. And the origin is 0, 0. So the velocity for the first section is 2 minus 0. So 2 minus 0 divided by 1 minus 0. You'll have 2 over 1, which is 2 meters per second in the positive direction. And then Roman figure 2, V is equal to 0 minus 2 divided by 2 minus 1 minus 2 over 1, which is minus 2 meters per second. And Roman figure 3 is going to be the same slope. You're going to get the same velocity. right? So this is the same continuous line, but let me just show you why you'll get minus 2. Here you'll have minus 3 times 0. Sorry, minus 3 minus 0. Here it's 3 minus 2. So I'll have minus 3 at the numerator, at the bottom we'll have 1. Right, so the answer would be minus 3 meters per second. Okay, so that would be the velocity on this section. Roman figure 3, which is negative. Okay, now let's continue to answer these questions. Reflect on the graph shown by answering the following questions. What is this? Is the slope, number 1, is the slope positive or negative for each graph, right? The slope, remember, we're calculating the slope here. You found the positive answer, so we'll say slope for this question is positive. And then for this part of the question, slope was 0, right? And this part of the question, the slope was negative. And then Roman figure 1, the slope was, we'll say, since it's positive, so here slope, we'll say it's positive. Here slope is negative. Here slope is also negative. So that's the first question. Then the second question is the velocity positive or negative? Okay, remember we've just worked out the velocity. Here we found, so the velocity and the slope will always link. Under the displacement time graph, they are the same. So the velocity will link with the slope, right? So if the slope is negative, the velocity will also be negative. So let's come to the third question. The third question, does the displacement increase or decrease? So looking at this graph, displacement time graph, you'd say that the displacement is increasing here, right? On this part, on this graph, this part, the displacement is 0, which is just constant. There is no increase. The increase is 0 basically. And then here, the displacement is decreasing towards the positive direction. And then here, Roman figure 1, displacement increases. And then Roman figure 2, it's decreasing in the positive direction. Now, when you get to Roman figure 3, that's where the trick is. The displacement is increasing, albeit in the negative direction. It's not decreasing, guys. When you see this graph going down like this, the velocity is not decreasing, or rather the displacement. It's increasing rather in the opposite or negative direction. So that would be question 3. Now question 4, is the displacement positive or negative, right? So just looking at the graph as it is, so anything that is above the time axis, you'll say it's positive, right? So anything above, so this one is still positive, displacement, and then still above the time axis here is positive, positive, positive. So here it's negative, right? The displacement here is negative. And then that would be the fourth question. And then the final question is, describe the motion of the object as shown by the graph. So the motion on the first question, basically the displacement is increasing here, as we have shown in the previous questions, in the positive direction. And then 10.2, the motion is the displacement here remains constant for 6 seconds and then decreases in the positive direction until 10 seconds. And then here, the motion is the displacement increases for 1 second and then decreasing for 1 second in the positive direction, and then start increasing in the negative direction for another second. So that will be the description of the motion. So we've come to the end of our today's lesson. If you liked today's lesson, please subscribe, hit the like button, and stay tuned on the next lesson. Cheers.